Hello everyone, welcome to this video. In this video, we'll be solving this question which states that find all the generators of these three groups Z6, Z8 and Z20, right? So let's first of all start with Z6. It is the group which contains the elements which are less than 6, right? All the elements starting from 0 up to 5 are present here. Here the group operation is addition modulo 6, correct? So here in order to find the generators, what we do, we see the cyclic groups generated by all the elements except 0. Why? Because when you add 0 multiple times, you would just get an element 0. So basically the set which is generated by 0 contains only the identity element which is 0. Right? This is the trivial subgroup. Now let's see the subgroup which is generated by 1. So here basically what we are seeing if you add 1 to itself once only, you get the answer as 1. 1 plus 1 is 2. When you take its mod 6, you get again 2, correct? 1 plus 1 plus 1 is 3. 1 plus 1 plus 1 plus 1 is 4. 1 plus 1 plus 1 plus 1 plus 1 5 times. This is equal to 5. And if you do it 6 times, so 1 multiplied to 1 by itself 6 times. So basically you are going to get 6, which under mod 6 is equal to 0, correct? So if you do it 7 times, you are going to get 7, which under mod 6. How do you calculate 7 under mod 6? You divide 7 by 6. You have the remainder as 1. So this is your answer here. So you see the elements start repeating themselves, correct? 1 into 8 would be 8. When you calculate 8 mod 6, you get 2. So the elements start repeating themselves. Hence, in the subgroup generated by 1, you have all the elements starting from 0, 1, 2, 3, 4 and 5. Correct? So this is basically equal to Z6. Hence, this would serve as the generator. Correct? So this member 1 forms the generator of Z6. Why? Because it generates whole of our group. Now we have to do the same procedure with the elements 2, 3, 4 and 5 as well. So you see when you calculate the elements generated by 2, you only have 2, 4, 0, correct? So this is not equal to Z6, hence this is not a generator. Let me show this for the element 4. When you have 4 multiplied to itself once is 4. 4 plus 4 is how much? 8. 8 under mod 6 is equal to how much? 2, correct? Then 4 plus 4 plus 4 3 times is equal to 12. 12 under mod 6 is how much? It is equal to 0. And then 4 plus 4 plus 4 plus 4 4 times. You are doing adding 4 times, so that is 16. 16 under mod 6 is equal to 4. So you see the elements start repeating themselves. Next element would be 20. 20 under mod 6 would be equal to how much? It would be equal to 2. So this is same as this thing. So you see we only have 4, 2 and 0 present within the subgroup generated by 4, which is not equal to Z6. Hence this is not the generator. In a similar fashion, you see 3, 2 are also not the generator, but we have 5 as the generator, correct? You can pause the video and solve for it. So here we see that the subgroup generated by Z6 is equal to that generated by 1 and that generated by 5. Hence 1 and 5 are the generators of Z6, correct? Now let's move on to the second group where we have Z8. So here the elements would be starting from 0 up to 7. 0, 1, 2, 3, 4, 5, 6 and 7. The group operation is addition modulo 8, correct? So we have to perform the same operation with all these elements. Now I know the process is lengthy. If someone watching this video know a shorter method, you can post it in the comments below this video, correct? If not, you can proceed with this method where we again check that all the elements generated by 1, those generated by 2, 3, 4, 5, 6 and 7, all the elements. So you see that generated by 1 is equal to Z8, hence this forms the generator. That generated by 2 doesn't. That generated by 3 is yes. I have written here how 3 added to itself one time is 3, correct? Then 3 plus 3 is 6. 6 under mod 8 is 6, correct? Next you have 3 added to 3 itself 3 times, so it is 9. 9 under mod 8 is 1. Then 3 added to itself 4 times is 12. 12 under mod 8 is 4, correct? Then 3 added to itself 5 times is 15. 15 under mod 18 is 7, correct? Next 3 added to itself 6 times is 18. So 18 under mod 8 is 2, correct? Similarly 3 added to itself 7 times is 21, which under mod 8 is 5, and 3 added to itself 8 times is 24, which under mod 8 is 0. Hence you obtain all the elements of Z8, correct? So 3 is the generator. 1 is the generator, 3 is the generator, correct? Similarly 4 is not the generator, 5 is a generator. Hence in this case 6 is not the generator and 7 is the generator. Thus the procedure is the same. So here you see that we have 1, 3, 5, 7 as the generators of Z8 because they generate whole of our Z8, correct? So this give you the answer for part B. Next we have for Z20. For Z20 we even have a lengthier process. Why? Because the number of elements here in Z20, they are 20 starting from 0 up to 19. The group operation is addition modulo 20. So you see for the group generated by 1, you have all the elements here which is equal to Z20, hence this is the generator. The group generated by 2 is not the generator. The group generated by 3 is a generator. 4 is not a generator. 5 is not a generator. 6 is not a generator. 7 is a generator. 8 is not a generator. 9 is a generator. Why? Because I have listed down all the results here as well. One could pause the video and you can check the results. 10 is not a subgroup. 11 is a subgroup. 12 is not a subgroup. 13 is a subgroup. 14 is not a subgroup. 15 is not a subgroup. 16 is also not a subgroup. 17 is a subgroup. 18 is not a subgroup. 19 is a subgroup. So here you see we have 1, 3, 7, 9, 11, 13, 17 and 19 as the generators of Z20. Now you might be thinking that if I come across such a question in the exam, how could I solve such a lengthy question in a limited period of time? So here, by looking at these 3 examples, we can make a conclusion here. I don't know if it is valid, but based on these observations, I have made this conclusion here that for Z6 we had 1 and 5 as the generators. For Z8 we had 1, 3, 5, 7 as the generators, and for Z20 we had these 8 as the generator. So now see the numbers which are less than 6 and relatively prime to 6. 1, yes, it is relatively prime to 6. 2, no. Why? Because the GCD of 6 and 2 is equal to 2 and not equal to 1. Next, the GCD of 6 with 3, it is equal to 3, not equal to 1, hence this is not a generator. GCD of 6 with 4 is how much? 2, which is also not equal to 1, this is not a generator. GCD of 6 with 5 is equal to 1, so 5 is a generator, correct? And similarly the GCD of 6 with 1 was equal to 1, which therefore 1 is a generator, 5 is a generator. Hence both 1 and 5, they are relatively prime to 6, hence both of them are generators. Similarly here also for 8, the numbers 1, 3, 5 and 7 are relatively prime to 8 such that they are smaller than 8, correct? Here 2 is not relatively prime to 8, 4 is not relatively prime, and 6 is also not relatively prime. And moreover here for Z20 the case is similar, hence this is the observation that I made, that the generators are the numbers which are less than n for Zn and they should be relatively prime to n. Correct? So I hope you understood this question well. Well, that is it for this video. Thank you for watching.